Sahil! Win again! What do we do first? Which double angle identity for cosine did you use?
Cosine square A minus sine square.
Okay, this implies then that you have to find cosine. So what did you use next? Does that make sense? Like we have sine, and I can put it in there. Whoops, why did I do that? 2/3 squared. But we need to find cosine. So here, what would you do?
Find cosine.
How would you find cosine? You can use a class, which one? Pythagorean identity. Cosine squared plus sine squared equals 1. Sine squared plus 2/3. Remember, sine we already have as a given information there. Equals 1. Cosine squared plus 4/9 equals 9/9. Are you with me? Subtract 4/9. C squared is equal to 5/9. Take the square root. C is equal to plus or minus the square root of 5/3. And cosine is? Positive or negative? Positive. Why? First quadrant. Okay, so we have cosine. And I can use cosine up here. So Sahil, did you get radical 5/3?
Yeah.
Okay, let's simplify the orange one here. Brandon, not here. Karina, here. Eileen C. And Leah. Okay, radical 5/3 squared. What's radical 5 times radical 5? Correct. Radical 25, which is 5, and then 3 squared? 9. 2/3 squared?
4/9.
And if you subtract those two, what do you get?
1/9.
Cosine of 2 theta equals 1/9. Raise your hand if you got that. And then, how do I find tangent? Now, you could do something like this. I probably would not recommend it. You can use the quotient identity of sine theta over cosine theta gives you tangent of theta. And then you can use tangent of theta inside the double angle identity here and here. But, why would you do that if I told you that you can use what? A form of the quotient identity. We probably want to do that. Talk to your partner. Why would we not do that? Because we don't have what? We don't have sine of 2 theta. So we're going to have to find tangent. No! Someone pick that up. Yeah. So sine of theta is 2/3. divided by radical 5 over 3. And then I'm going to change that to multiplication. So I'm going to get tangent of theta equals 2 over radical 5. You could rationalize that, but we may not even need to use that. So let's use this one. Now I'm going to use the double angle identity for tangent. So we are going to use that. From my formula sheet, 2 times tangent of theta over 1 minus tangent of theta squared. I'll do the substitution here and here. So I'm going to have 2 times 2 over radical 5 over 1 minus 2 radical 5 squared. And I chose not to simplify or rationalize, hoping that I don't have to do that in the future. So I'm going to have 2 over 1, so that becomes 4 over radical 5 divided by 1 minus, this becomes 4, and the square root of 5 squared is just 5. So this will become 5 over 5, so 4 over radical 5 divided by, this becomes 1/5. And then 4 over radical 5 times 5 over 1. So now I'm going to have to rationalize. So I'll get 20 over radical 5. So now I'm going to rationalize. So now I'm going to get 20 radical 5 over 5. And 20 divided by 5 is 4. 4 radical 5 is the double angle identity for tangents. So fine, we found cosine of 2 theta and tangent of 2 theta.